Good morning, guys. Today we're going to go over 6.6, which is pretty much solving logarithms and exponential equations. Now, one thing to keep in mind, there is a property here which we will be using to do all our solvings. And it is incredibly easy, thank God. Pretty much, it's called the equality for exponential equations. And what it states is, if I have this particular expression, the only way this can be true, this equality, is, since my b is the same, but these are two different letters, the only way this can be true is if my x's and my y's are different, are identical, even though they are different variables. If these two are the same, then this equation will be true. For example, as stated in the book, for these two to be equal, what must my x be? My x has to be 5. So x is equal to 5. Even though it might not make much sense now, that's how we solve pretty much our logarithms and exponential equations. For example, if we're given example 1, let's go over each example and do every exercise. They're telling me that 100x is equal to 1 over 10 x minus 3. Okay. Entonces, in this particular case, step 1, I need my bases to be identical so they can then be canceled out and be left with only the exponents. So in order to begin, what I do is I have 100x equals 10 to the negative 1 x minus 3. That's Ariana. She wants to say hi. Give me a second, please.
Hola.
Di hola.
Hola.
Hola. Okay, di bye-bye. Be right back, guys. Give me a second. Sorry about that. I just don't want to begin from the beginning. Okay, so in order to continue, sorry about that interruption. Now still, I'm working to end up with the exact same bases here. I have a 100 here and I have a 10 to the negative 1 here. So still quite a ways off. Now, first of all, we have a power of a power property here. So let me go ahead and multiply this times this. This is going to turn into negative x and this is turned into positive 3. So I got rid of that negative exponent. Great. Now still I have to continue working with this. Notice that here I have a 100 and here I have a 10. You should know that 100 is the exact same thing as 10 squared. Same thing as 100. And again here I have power of a power, so I substitute that 100 to the x to this particular expression. Now, since my bases are the same, I can apply the equality for exponential equations. All you have to do is cancel out these bases that are identical and you just work with the exponents. And from this point on, you just isolate your x's as normal, factor, etc., etc. Let's send all my x's this way. So you're going to add x and subtract 2. So I have 2x plus x minus 3 equals 0. When you combine these terms, you're going to have 3x minus 3 equals 0. Now to finish, we have to factor. Yay! Factoring again in order to find the solutions. So all I have here is a 3 in common and that's pretty much it. So the solution to this, what number do you plug in here to get 0? The solution would be a 1. That's that particular case. So notice here I wasn't given any logs anywhere. You're just given exponential, you're given exponential functions. So the whole point here is to end up with the exact same base, to cancel them both out, and then just work with the exponents. Then you have to find the solutions. There's a whole bunch of ways to work the solutions. But again, very long process, but it's important. That was the first example. Now, here, note this problem. Now we have a different problem. I'm given this sort of expression, and note that I have no exponent here, so there's no way I can do x equals something at the end, because I have nothing for an, well, I have a 1 as an exponent, but that's not what we do. Entonces, what we do in this case, it's called exponentiation. We kind of did this in class. What you do is you raise this to log, or you multiply this, log base 2. I multiplied this by log base 2, and I also multiplied this side by log base 2. Since these are identical, that's the same thing as, it gets canceled 1, and this x drops down. Now, many people ask, Profe, how the heck does that x, that is an exponent, just drop down here? Again, remember the rules of the logarithms. This log, this is a power. It comes up to the front multiplying. So I have x log base 2 of 2. I know this is 1, and x times 1 is x. So x equals log base 2 of 7. Calculator, don't go crazy. Calculator, that's the answer. Now note that the trick is, again, the first step. How am I going to begin working? If you're given two expressions with two exponents, that the bases can be somehow worked to end up with the exact same base, you do that and cancel them out. If you're given an expression like this that has, usually when you see an expression like this, like 3x equals 17, again, you multiply the base times this number and you do log base 317. Calculator, and you're done. So that's it for example 1. Let's go over example 2. Example 2 is a real life problem. No, we're not going to do that. And una cosa, the exact same thing that applies to equations also applies to logs. If you have the same base, the only way this expression can be true is if x equals y. So you can just cancel the logs, work with x equals y to find the solution. For example, if they tell you log 2x equals log 2 7, cancel the exact same logs, and that's your answer. Of course, it's never going to be this easy. It's math, so it's always trying to make your life more complicated. Let's look at examples 3. Example 3, the first one is pretty straightforward. The second one is. Well, let's go ahead and do them both. The first one, they're giving me natural log 4x minus 7 equals natural log x plus 5. You should know that these logs have the same base, natural base e. They cancel out, and you just work with the expressions that are left, and let's solve them. Again, I'm going to send these terms to the left, minus x minus 5. 4x minus x is 3x, negative 7 minus 5 is negative 12, equals 0. Common factor 3. X minus 4 equals 0. The solution to that one would be 4. That's part A of example 3. Let's do part B. They're giving me log 2 5x minus 17 equals 3. Entonces, here, again, we do exponentiation. When you're given two logs, you try to reach the same base, just like the exponents, to cancel them out. If they give you one log, just like they do in the exponents, here's where we do exponentiation. What you do is, you raise this expression, and this whole thing now becomes an exponent. Exponentiation, you can do that. And this side, this whole expression now becomes an exponent. So now I have 2 raised to this value equals 2 raised to the third power, or 3. And if you can recall, when we're working with logarithms and exponents, the exact same thing happens. This cancels out and this drops down. So now you're working with 5x minus 17 equals 2 to the third power, which is 8. You're going to isolate and work as normal. Plus 17 gives you 5x equals 25. Divide by 5, x equals 5. And that is the solution. Now today, we're only going to work those 3 examples. But I want you guys to really practice them. I'm going to give you homework, and I want you guys practicing. Why? Because tomorrow, Thursday, we're going to do the other half. Then you're going to have Friday, Saturday, and Sunday to study for the test, which will 90% sure be on Monday. Might be moved to Tuesday. Not sure yet. Not sure. But just study as if the test were Monday. Okay? Remember, it's going to be this test, possibly one more test, and then project till the end. So just hang in there. You guys are doing a great job. Now, again, today's homework is going to be long, but you're going to have until tomorrow to upload it. Why? Because this homework covers all the things we see in chapter 6, all the things we saw in chapter 5, and factoring. So it might take everybody a while to do, and it's incredibly important that you do these problems. So again, for the homework, it's going to be long, but you have, actually, you know what? I'm going to give you guys the entire weekend. You're going to have the entire weekend to work these problems, including tomorrow's problem, to prepare for the test. So this homework is due Sunday before 11 p.m. Sunday before 11 p.m. I do not recommend you leave them all for Sunday because you will not finish. They are difficult. That's why I'm giving you extra time. You can do a few each day so you can practice every day. Now, please do 5 through 16. And again, these are difficult. They are difficult. I'm giving you 3 days to work them. They are difficult. And please do, actually not all of them, to 11, 5 through 11, and also do 21 through 27, 6 and 6. And again, you have until Sunday to do these. These are pretty much all exponential functions, and these are logarithmic. Make sure you find the solutions. If you have problems, let me know. Okay, schedule a call. But do try to work them. Get them, it's okay to get them wrong a couple of times. Don't just say, I don't know how to do this, let's call profe. And no. Really try. That's why I'm giving you guys 3 days. Because these are exercises that will use everything you've learned, this past half year to solve. So, you got to review a lot of subjects and practice them a lot. If you have any questions, let me know. If you want more exercise to practice, tomorrow, after I give the second half, I might give just like a practice sheet for the test, but it's not going to be actual homework. The official homework is this, and what I will tell you tomorrow is the official homework. If you have any questions, let me know. Otherwise, have a great day. See you guys soon. Prepare for the test because it's going to be a little difficult.